Hello and welcome. This video is just meant to showcase the current progress of my current game engine. So first test is going to be a little bit simple. It's just going to involve 40,000 physics bodies, actually entities, game entities, kind of being simulated and moving around. And so a couple things to mention. First off, yes, it's eating up like very few milliseconds and it's performing 60 frames per second on this old DDR3 era, somewhat 8-core CPU from forever ago. Like, it's doing pretty well, and it's single-threaded. But, to be perfectly honest, it is using axis-aligned bounding boxes, and there's only, one possible... Like, there's no concept of fixtures. It's just one body or one fixture per body, if that makes sense. So it helps, keep things pretty simple. But, yeah. For the purposes of my projects, it works out pretty well. I'm having a little bit of fun with this. Sorry. So, I'll be going over into why it runs that well, but if I were to be, like, perfectly honest, it's kind of doing that well because the bodies aren't entirely cramped together and all that, and I forgot to get rid of this inner loop still. Whoops. But if I were to spawn all of these entities within a square about that dense, as you can see, the frame rate generally drops. It takes a lot more milliseconds, and a lot of this is just because there's a lot more of them clustered together in one small area, and it's using a spatial hash table, and they're kind of like constantly doing a lot of crossovers and just a lot of collision checking going on in general. So yeah, that's basically why. But, like, even for that, 40,000 I don't think is too bad. But, and sorry for being really, really rushy with the video. I've recorded before, but I kind of need to hurry up and get it done because it does take a fair bit of space on my drive to get this recording done. And I don't want to take forever, and I'm having too much fun with this. So, the game engine uses a custom axis-aligned bounding box-based physics engine with a spatial hash table. It uses entity component systems, of which they grab game object data can be grabbed from text files, which I guess I can just go ahead and show that off right now. Oops, wrong folder. Right-click. There we go. So, I'm going to back out to here. So, my current engine design is... or my current project design is such that I have different folders for different different project things that I want compiled into their own executable. I'm not sure how I'm going to be able to port that, but I kind of do really, really, really need that feature. But let's see, within our data folder that they're all easily able to reference, let's go to entities, drone. So this is basically what it looks like. Now, how do I explain this? So basically, all these are components which get put, which are created and emplaced within, every entity that is made based off of this text file. These are comments, obviously. And yes, this is using a custom parser. A lot of people probably don't like that idea, but it's really simple in how it works, so I figured why not just make something, because there's really no point using something like a JSON parser and then having to deal with all that indirection hell, and it just ain't worth it. And I really don't want my entities either having to deal with a bunch of indirection either. Or my ECS stuff. Anyway. So I haven't made it to where I can use floats yet. The only types that are allowed currently are... I probably could easily put floats in there, but the only types that are allowed currently are nulls, which don't take up any space, integers, strings, which are actually stored as only 4 bytes, not an actual entire C string, and I'll show as to why that is later, and arrays, which can have whatever number of elements. It's just required that every component with array type has, equal length, equal number of elements. So because these are 4 bytes, as well as integers being 4 bytes, and when I put floats in there, there'll also be 4 bytes, I can optionally create an array of whatever combination of strings and numbers that I would ever want, because they're all 4 bytes each. and it makes it like it's not really complex at all. My code can pretty much handle that fairly well. Surprising as that may sound. I'm just gonna leave that there for now. So to sort of demonstrate that this does in fact have an impact, let me just comment out this line really quick. Rerun. Taking a bit long, I could probably fix that later. But yeah, you don't see the sprites there. The entities are still there, they exist, but... And that happened because I shot entities out of bounds. I just need to put, like, physics bodies around the edges of the world so that way when stuff collides with them, it destroys themselves or something. But anyway, but yeah, it's really, really super, like, easy to design game objects because of this. I can constantly test and tweak numbers without ever having to recompile, which to me personally is a really, really big plus. I'll go ahead and get rid of this just for the sake of not forgetting that it's there later. Comments can also be multi-line comment. In fact, I think I have an example in here. There it is. So they can look like that. You can type whatever you want in that, and nothing bad happens. So next, I think I shall go into my, I shall explain how the AI currently works. I'm using a utility-based AI. It's not entirely a utility AI, not done proper anyway, but it's based on a lot of the concepts, and it probably will evolve to a proper one as I spend time working on it. To be fully honest, AI is still slightly a new field to me, but I've studied the concepts a fair bit, and I'm just really interested in properly applying them. But so anyway, the way this works is that I have this component right here that's grabbed for every drone entity. I mean, yeah, that's created or emplaced within every drone entity. And then, so this string is stored as a 4-byte ID identifier. So then I take the string out of that, and then in my system's AI thing during the initialization phase, it looks for every entity with this component, and then it searches for the file referenced in that string, which points to here, and then grabs all the components from this file, and then puts it into said entity. So the way that utility-based AI works is basically you're just messing with how do I put it? You're tweaking values to different actions. So like chase enemy if in range. This is your range modifier, and then this is your like how valuable that kind of how valuable that action is type modifier. So you could do some custom math like divide this by this. I think I might be thinking of that wrong, but something like that. And then shoot enemy if in range, and retreat if health less than. I need to tweak these because they don't work properly as how I would imagine. Maybe some math internally is wrong, but like the concept still seems to work. And the fact that I can just play with the numbers and see what happens is really, really cool. So yeah, there's all that. But I guess I'll just go ahead and demonstrate how how AI basically works. So actually, to showcase how slow the AI is currently, let me just run this. So I don't have any pathfinding yet, nothing fancy. I normally have stuff printing out in the debug console, but I currently have that disabled so that I can just showcase this. But all these things, oops, I'm stuck. Well, still, you can kind of see what's going on. So it takes about 8 milliseconds to run the AI system, and what's going on is that every single entity is about every 100 frames randomly, individually, everyone. They run their AI logic, and what it does so far is just simply grab all physics bodies within a certain area near it. 640 by 640 currently. I might stretch it out later, but yeah. So it does that. It figures out the owners of those bodies with the user data pointer, because that points to the entity, the owning entity. And then from that entity ID, it goes and then figures out, does it have X and Y components, and yada, yada, yada. So basically, these check for if there's any other entities that have also a team component, and if that team component happens to have a different integer value, and then they'll know if, like, they're friendly or not friendly, or so and so. and then from there they'll do their combat logic based on that. So I don't have pathfinding, sadly. I don't really have much fancy going on there. I plan on using. I'm debating between A star and then just a custom nav mesh, but I think I'm going to lean towards the custom nav mesh for the projects I'm wanting to work on, which are like a bullet top-down bullet hell that has mechanics from like Dynasty Warriors or Samurai Warriors, if you've ever played those games, with the Toho theme, because why not? Phantom's big. It's generally expected that most games made for it are in the free market, and it just, I don't know, I might get a lot of feedback that way. Anyway, but yeah, so that kind of shows, like, for 40,000 entities, and for them individually checking within an area, like, what physics bodies are around them, like, that, honestly, that doesn't seem really bad performance-wise to me. I could probably improve it, but still. And it just kind of proved that, wait, where is it? There he is. And it just kind of proved that it indeed is the area of which I'm searching that affects it so much. Let me just, like, knock this down to 6x6. Why not? That it should only check, like, 1 hash per. Yeah, I really need to fix the initialization time. So many entities. So yeah, like 2-3 milliseconds, that's like nothing. But then sadly, if you were to go up to like, I don't know, what I originally wanted to do was like 2000 by 2000. You pretty much get just insanely horrible, horrible, horrible performance. I think it's like 23 milliseconds or more. We'll see here soon. Ooh, oh yeah, that is twice as big as I thought it'd be. But that gives you a rough idea. But see, like, you almost never have that many AI running within any game or simulation in the first place. So, I'm actually still quite happy with it so far. I don't think it would get that much worse performance-wise once I put in pathfinding and all that, but, like, it obviously is still going to take a hit, but still, like, just even having 1,000 AI-based NPCs moving around is pretty awesome. And I imagine I could go, like, a few thousand without any trouble whatsoever. Even on low-end hardware, which my hardware isn't exactly high-end either. So, to demonstrate how the AI roughly work, let me just uncomment those. Keep that running. Let me just, like, oops. Let me just, get rid of this. Oops, no. I want to comment you out. Uncomment you. Sorry. There we go. And then just, like, set that to 1, so that way I only spawn one entity relatively close to the player. Alright, so we're gonna have to look at the debug console to really see what's going on. So, if I go far enough out, you should see that this stops, which it does stop printing. Now if I go back, currently for whatever reason it wants to retreat when I'm far away enough, because I do have its health value like super low, and I wanted it to be like if health less than, I think it was 50 or something, it retreats. But then I get closer and it wants to chase, and then if I get close enough, it wants to shoot. Right about there? There? So, I obviously still need to tweak the values and figure what's going on and maybe work on my math a bit, but, like, the concept in principle seems to work, and I'm pretty happy with that. Obviously, there's going to be some complex scenarios going on, and when there's pathfinding involved, it's going to get way more nuts, but yeah. Still, not horrible. So, that's the AI system roughly explained. Allow me to go over the physics engine. So, oh, actually, I guess I could go over the entity objects. So these guys are what gets created when I load in data from the text files to create the entities the game entities. Excuse me. So, all these are, it can optionally be, like I said earlier, null, int, string, array, except string is actually of type name. Where is it? Here we are. Which is used to compress, or sort of, store an ID per individual string. I borrowed this concept from UE4, obviously, if anybody's ever messed with fnames in that engine. But it's a lot more simple, even in UE4 itself. I would rather use this because that engine has, like, at least 12 bytes or something reserved for every fname, which I find annoying. I'd rather it just be 4. And they do a lot of extra weird checks that I don't know what the hell it's about. But, yeah. So that helps compress my strings a fair bit, so that way it's just easier to deal with this stuff. Maybe a bit more optimized in some ways, but, like, honestly, I've had a lot of uses for this outside of even this. It's just really, really awesome and handy to have that. So, yeah, I just roughly use this to load in strings from files and all that, and then parse it and yada yada yada. So, before it gets to the flat buffer, yeah, let's look at the physics engine. Where did I put it? There it is. Okay, so I probably should have just used a straight up vector of ints instead of this templated mess. It works for the most part, but there's some quirks to it that makes it feel weird. I don't know. Maybe it's okay. I don't know. But, yeah, it does some simple stuff. Is 0, normalize, get distance, yada yada. It can work with other templated types like byte-sized members for the vect, or if you want floats or doubles or whatever, it can somewhat work between them. Sometimes I have to, like, manually cast individual members for whatever reason. But anyway, so in this physics engine, bodies, as I said earlier, are all axis-aligned bounding box. I could probably strip this out of the body, or out of the object itself, and then move it into its kind of like own array, and that probably would be a lot more optimal. I'm not sure yet, but I just did this for the moment because I'm lazy, and I also wanted to see what the performance hit would be like. I probably should move it below these, and then make sure if I put any other states that they all stay clumped together to avoid struct padding, but anyway. Next up is body ID. So this guy I have here because I have this same kind of physics implementation regardless of the actual physics engine used, if that makes sense. So this is like, my stuff here is overall like a kind of a wrapper, or my physics engine is kind of like a wrapper. So I could replace its functionality with like calls to say box2d or chipmunk 2d or such and such. So because of that, and because my stuff uses an integer ID, whereas their stuff uses a pointer, I use this to kind of wrap that and make it to where I can easily just swap out the back end, and it works perfectly fine. So, oh man, it's still so nostalgic looking at this. So my broad face is just a basic spatial hash table. I love using templates for stuff like this because I can just like pre-allocate everything in one go, and it not having any performance impact compared to how most do it, where they'll like where they'll have like a dynamic array to a buffer of hashes of where each one has their own array to like a buffer of object pointers, and it's just like, I'm not a fan of that kind of indirection. I'm pretty sure I've had performance gains doing it this way anyway, but like, it might not even be this. It might be the other stuff I have below. I should probably do some more thorough testing. But anyway, a bit messy, I admit, but at least it's somewhat manageable. It's not as bad as my ECS library, which I'll get into later. So for the physics engine itself, I have to define a max body count to feed into the spatial hash table and all that, in other arrays. So then there's unit size, which is just to kind of emulate decimal points despite the fact that I'm using integers. And there's quite I just don't like using floats for physics, honestly. Like, even if there's not a performance gain using integers, it's just the fact that I can easily serialize and and send stuff over the network. At least in theory, I haven't actually tested it yet. It just feels a lot nicer, and I don't know. I feel like maybe I want to do lockstep, and if I'm gonna do lockstep, it's just gonna be a lot less hell if I avoid floats altogether. So there's that. And I can easily translate floats being fed into this into the proper integers using actually this, because then I could use some multiplication or division depending on if it's coming in or out, and then just tweak the numbers as they come in. So, well, come in or go out. So, my physics engine and my ECS library both use a lot of these custom types called flat flag buffer and then flat buffer. This one particularly is rather interesting. So the way most physics engines work is that they have this like array of pointers to physics bodies, and then they'll like allocate or deallocate these bodies as they're being created or destroyed. And to me personally, that seems like a horrible mess for one runtime, and a horrible mess just for the fact that you're allocating to deallocating a lot. Like that alone, even if it doesn't mess around with runtime, I personally like to have all of my stuff sort of allocated up front. That way I have in my head a mental model of what the absolute maximum of things are, and it doesn't change. So that way if I create messy ass gameplay at one particular spot, I just sort of... I'd rather the game crash doing that than like completely chug up the system RAM and then slowly eat away at it and all that. I don't know, maybe that doesn't make sense. I'm a little weird like that. But anyway, so this guy is actually really helpful. I've used it in several other instances too, where I needed like flat buffers, where I needed to add and remove elements. So anyway, the way it works is that, so you have a large fixed length buffer of objects, right? So you want to be able to emulate the concept of creating and deleting objects. Well, one way you might think of doing this is just how you would normally do, where you would pop off the element or last element from the buffer and then like copy that over to the index that you're wanting to remove. Well, that works for pointers, but the reason why it doesn't really work for regular objects is, so for the physics engine, for example, what you're doing is you're invalidating ID references that reference the bodies here. So like if I had an entity that was pointing to body 5 and then, or it's the last element, and then I remove the last element and then put it into like index 5, then it never knows, it never gets updated. Actually, that might not be the best example, but I mean, still, I've had that issue a lot, or issues like that. So the way this gets around it is that it has the obvious buffer of objects or whatever type you feed into it, and then there's this hidden array of what's called isValid, but it's just like it's a buffer that tells you if any given element is valid or not. That's all it is. So if it's set to not valid, then you know that the object isn't usable anymore, and you consider it cleaned up. Even though that all you're doing is flipping a single flag, it's a lot less work than having to deallocate something. Max index? I don't remember that being... Oh yeah, I did need that. I don't remember if I actually need this. That's weird. Anyway, so I was originally going to make this buffer an array of bit flags, if that's the right terminology to use for it, but I had it working earlier, I swear, I think, but I lost it, and then I tried making a new version of that, and it didn't work for a while, so I'm just stuck using bytes for now. But let me get to why, even despite that, I can still optimize this pretty well. So if I were to insert an element, what I do is I look for the first invalid element, I toggle it to be valid, and then I copy the data over from what was passed into here to the data buffer. So the interesting bit, though, is what's in here, which, if we look up, is right about here. So what we're doing is that we're casting the address of this buffer as a buffer of uint32. And the reason why this is performant, or why I do this, is because it's performant, and it's because the amount of times I have to loop over this array is 4 times less. So to explain it basically, for every 4 bytes, I check all of them within one variable against -1. And if it equals to -1, then we just continue and we keep doing this and doing this. Now, the reason why this makes sense is because my valid value, so to speak, is 255, which means it's literally the max value for every byte. So I just keep doing that. I mean, it doesn't matter how many bytes you have together to form that one variable. As long as you check that one variable against -1, as long as they all have this, then you know that they're all set to valid. So I thought that was pretty cool. But yeah, but if this becomes false for whatever reason, we loop over all the individual bytes until we find one that is not valid, and then we set it to valid and then return that particular index. So for my initial testing, doing it that complicated way is actually about, on this CPU, 3 times more performant overall than just like checking it the typical way most people think of, where you check 1 byte at a time in a for loop for some reason. I guess you could chalk that up to both data compression and the fact that you're looping a lot less often, so the instruction pipeline is getting flushed a lot less often. So there's that. But yeah, that's like, I guess, just about all the important stuff. Normal flat buffer is kind of similar, but it's a lot less complex. It doesn't have that fancy flag stuff going on. I'm not even sure if I actually need this. I just made it because I wanted something with I wanted something that could kind of pretend that it's a fixed-sized vector without being forced into doing things like normal vectors are. I don't know, but like optionally doing it. I don't know. Maybe I don't really need that. But anyway, so yeah, there's that. So yeah, because of that, I can keep all of my physics bodies literally within one buffer, perfectly close together, and it's just a lot more friendly to the cache line overall. So apologies for sounding nervous as heck. I actually think I did better in my first recording, but anyway, so the physics engine itself, to run it, it's not a proper physics engine in that it doesn't do interpolation between frames and all that. I find that personally kind of annoying, because I expect my games to hit a certain frame limit, and if they go lower than that, then I figure that's a fail regardless, and I don't want to have to deal with it. But that and not dealing with interpolation does reduce the calculations quite a fair bit, at least in theory. I should probably implement it in a different version and see how that turns out. But anyway, so first we simulate, detect, resolve, the typical 3 steps you would do. So in detection, or in simulation I mean, everything in this engine is so far just single-threaded, which I find impressive that it's able to mess with that many bodies and single-threaded CPU side of that. Even though they're all simple bodies, but yeah. So the only thing that's like writing stuff in here is this messing with the spatial hash table, removing and then adding bodies. If I could figure out how to like separate this to where they're not one thing's not reading something that another thing is writing to with the spatial hash table, I could multi-thread this. Maybe I could grab all hashes within a certain area and then separate it out and then simulate the bodies with them individually or something. I think that, what was that one game? I think Noita does something like that, but I can't quite remember. I don't know, that might be more hassle than it's worth. But at least within, like, detection for the most part, I'm not really writing to anything. I'm more or less just checking and then kind of dealing with this, I think, within these methods. And then these are all separated, though, so I don't have to worry about one thread touching stuff that another thread needs to read. So because of that, I could definitely multi-thread this part and then help performance with that quite a fair bit. And that's probably more calculation intensive than the simulate part anyway, because you're actually having to touch a lot more data. Resolve, let's see. Resolve, I might not be able to multi-thread for the same reason as simulate, because we're adding and removing stuff from the spatial hash table. But like, maybe. But like, if I could even just multi-thread this part, that would be so cool. So yeah, there's that. So there's some room for improvement here. It's fairly, the engine overall is honestly ugly. I need to add proper comments, remove all the dead code that I had commented out, and some other general cleanup and design improvements. But yeah, there's all that. So let's see, what else do I have to show off? I think that's everything except the actual ECS library that I came up with. So this right here has to be like the ugliest part of the engine in my book, because let me just go through it. So we have entity IDs and then component IDs, which are just UINs as they properly should be. Now internally within the library, I have an entity struct, which isn't the same thing as this. It's just like, I couldn't figure out what the hell else to call this, but it's basically meant to just be like a big buffer of component indexes. And then so what you do is that you take the type ID or the component ID, and then you look through this buffer to figure out, one, if it's valid. Like, if the this entity has that type of component, this will tell you if it's valid or not. And then two, if it is, then you grab the index from, you grab the UN index value from there, and then you know exactly what index that this entity references, if that makes sense. So then we have our component buffer stuff. This is pretty ugly because it references, all these structs kind of touch things from within each other. Like this DDECS struct touches things from in here, and then vice versa, and I find that a bit annoying. I can't figure out quite yet how to get around that, though. But so far it's been running pretty performant. Even if not for the physics engine, the flat flag buffer is perfectly, like, super handy for the ECS engine, keeping stuff nice and flat and compact. So, and there's definitely some polish I could do to this, and more functionality I could add. And I've not even really added proper systems logic either. I just kind of use global stuff externally outside the engine and then pretend that it's systems, more or less. I don't know how else to think of it or how else to do it yet. But, yeah. So, get entity component as I created after this became a bit sloppy and hard to deal with. It's pretty much self-explanatory. You feed it in the type that you want. You still have to feed it in a component ID, unlike ENTT. Now, the reason for all this, for the fact that I have to deal with component ID so much, is because oftentimes I want to grab data from files, and unlike code, you can't get static type data from files all the time if you're dealing with like mods and such, because it's just it's just generally hell. I'd rather deal with the component IDs being computed runtime manually, and then just feeding it in straight into here, and then letting the user deal with it in whatever scripting environment that I happen to come up with. I don't know, just it feels generally a lot easier to work with. I really like data-driven type game design that also happens to be really decently optimized. But anyway, yeah, this works pretty well. You generally need to use this before you use this if you're not sure if an entity has this type of component. So unfortunately that does mean extra checking. Now the way I used to do it was this, where you didn't have to necessarily use this, but this would just like return an address from some sort of a component buffer, and then you could easily tell if it was valid or not just by checking if this was null pointer. And then if it was valid, then whatever this returned, you would do a lot of casting magic to sort of get your type out of it, which personally I really kind of hated. It's just ugly. You got like type pointer, and then pointer here, and then God knows what else. It's just awful. If I could figure out a way to simplify that and yet still keep this the ability to check no pointer on something to avoid this extra overhead, that'd be awesome. But so far the overhead for this doesn't seem that bad for now. I might have to deal with that later, but for now I'm good. So yeah, there's all that. There's the custom ECS library. Now, yeah, the reason why I made this is because ENTT doesn't have accessible documentation or examples of how you would deal with creating components from strings from like files, like how I'm wanting to do. So I just got annoyed enough there where I said fuck it and I did my own thing. And this seems pretty optimized despite that. Like honestly, I would love to compare this with ENTT and then see what performs better in what scenario. I don't yet have a thing where I can like grab all entities with X list of components and then just have it like pre-buffer this list for me type thing. Like that would be a really cool optimization and code cleanup thing to have, and that probably wouldn't be too hard to add, but I don't quite have that yet. That's one of the few things that are missing. So yeah, I mean, it seems insane in that ECS library was an absolute pain in the butt to make, but like I really feel like it was worth it in the end. And it's not too hard to add functionality to gradually as I need stuff at this point, thankfully, surprisingly. But yeah, that's most everything. Um, yeah, pretty much most everything. I feel like there's something missing. Oh yeah, well, the only thing I haven't covered is like my I/O stuff, like the rendering, the handling input, and all that. And the way I do that is, don't worry about all this text. Most of it's kind of garbage at this point. Not necessarily true. And I probably need to tweak a lot of things about this API, but it's just a simple C API, kind of influenced heavily by SDL, I guess you could say, and then a couple other things. But I wanted to keep it more simple and generic and like specific for my purposes. So you define these three functions in your program. It handles initialization from like main and all that on its own, uh, internally depending on implementation. So but like this is just the straight header file. It doesn't really do much of anything. It's just your function definitions more or less. I tried really hard to avoid custom types and all that, just to keep it more sane, because I might have different internal types depending on like what backend I use. This obviously isn't going to work if you really need to know that data for things like if you're building pixel-based physics, because then you would need actual like color data, unfortunately. But anyway, so yeah, there's that. So the way that this is dealt with currently, and I could probably do this better, is that in this file right here, I just include whatever header that has the implementation code that I want. And right now, currently, it's just using SDL2. I could probably, for Windows, honestly, just use my custom Windows rendering backend after I give it some tweaks, but I probably will do that eventually. I don't know. It depends if I want to keep this cross-platform or build a custom thing for Linux and then swap it out for Linux or such. I don't know. But the fact that I can like swap out the backends and then just test what the differences are is like really super cool. Anyway, I'm surprised. Oh yeah, I had to get rid of these because of the engine layout. That sucks. Anyway, yeah, so function definitions can look like this, generally. This is kind of a cheaty way for me to know where my data folder is at, and then I return it through one of the functions here. Like, it's pretty much self-explanatory. I just wrap all the complex SDL crap into whatever I need with whatever error checking I see fit, and it seems to work pretty well, surprisingly. So, yeah. I even think I have a PS1 implementation I was working on. Oh, no, I didn't actually really work on it. I just grabbed the syscall header thing that they had. But that would be so cool to have one working for the PS1. I'm actually quite fond of deving on that console. But yeah, there's all that. I think I went over pretty much everything in the engine. That's remotely interesting. I was working on making trying to come up with a custom like UI library. I really suck at UI design, to be honest. But I figured for games, it just needs to be simple. Buttons, maybe sliders, just basic stuff. And I try to keep it really rendering agnostic, so that way I could port this more easily, which in turn has created interesting complexity all on its own. And then I figured out stuff like events for like mouse clicking and then mouse pressing and all that. It's really not straightforward in how you implement it, so it's a bit hell to figure it out, but it kind of, at least there's a rough prototype. But yeah. So I plan on making a few large scale, by large scale I mean I plan on making a few game prototypes with this that are just like, they might not have really that interesting or that much of an interesting set of fancy mechanics, but they're at least going to have high entity counts. I don't know why, I've always found that interesting. I really can't be satisfied with a project unless I do something like that. Unless I like really push the engine to have as many things in the world as possible that are interactive and that are dynamic and do their own things for some reason. I'm a big fan of like really large scale RTS games or Factorio. The Total War series, I guess you could say, is a big influence. And I do like the Dynasty Warriors / Samurai Warriors series, but I feel like they could have done so much better because they kind of cheat a lot of stuff and then fake a lot of things in the background using the morale system and all that, unfortunately. I feel like the whole thing could actually be simulated real time. But anyway, so yeah, that's pretty much everything. So feel free to leave comments and such below. Actually, here, just to show off how easy it is to test things or to change stuff, let me just like comment out this health component just to sort of show what goes on. So doing that, we run this. And then remember how earlier I was shooting the other entities and they would immediately disappear? It's because they were taking damage, and then I had a, if damage was like sufficient, I would add a is dead component or something like that. So because I removed that health component, that calculation is never taken, and this can never actually be deleted. Literally, all I have to do is just tweak a text file. Just add this back. And obviously that isn't going to reload on its own. I have to rerun the thing. But then there you go. No code tweaks required whatsoever. So yeah, thank you for watching. Please leave critiques below. I do feel like I should take some pointers on how to improve this overall. I generally don't care for just making games for the hell of it, or making games like most indies do, where they just spam a bunch of prototypes and then sell as much crap as they can and then get as much like public attention as they can. For some reason, I actually like making large-scale projects, which tend to take a lot more time and they tend to require a lot more custom work. There's no way in hell I could accomplish anything like this in a pre-built engine. Well, I could. It would just be a lot harder, because I would still need the custom physics and the custom ECS, which I've actually already ported the ECS library over to UE4. Surprisingly, it somewhat works. But yeah, I end up fighting the engines most of the time. They're usually too locked down in their own design to be able to really, besides like Unigine, they're for the most part really too locked down to deal with. But yeah, I would appreciate feedback, and I hope you all have an awesome day.